Hello guys, okay. Today we are going to look at this interesting question. As promised yesterday, we are going to do some elliptical integration or elliptical function to find the perimeter of an ellipse with the given equation of the ellipse. Okay, so first I'm going to derive basically the elliptical integral using the general form of the ellipse equation. Okay, so as we know, the equation of an ellipse at a center origin, okay, 0 0, is given by, okay, the general formula is actually x, okay, minus h over a square plus y minus k square over b square is equivalent to 1. So for the elliptical integral, we are going to consider at the center of origin. Center of origin is 0 0, which makes h equals to k equals to 0. So now we have to consider x over a square plus y over b square equals to 1. Okay, so so the ellipse will look like this probably. Okay, so this is y-axis, this is what x-axis, so it would look like this, for example. Okay, so the center is at origin. Okay, so like that. So our intention is to find the arc length, so from here all the way around 360. So what is the perimeter? So in order to do that, we need to use elliptical integration. Okay, first of all, from our polar coordinate knowledge, we know that x equals to, I will use parameter a cosine theta, okay, and also y equals to parameter b sine of theta. So the parameter b is based on the semi and also major and semi axis of the ellipse, which is a and b respectively. Okay, so for a, it is associated with the x axis, and b is associated with y axis, okay, or the variable y. Okay, then we need to take the derivative. So the derivative of x with respect to theta is minus a sine theta d theta. Okay, and for dy we have b cosine theta d theta. And then recall from our prior knowledge about the arc length formula, it is ds. So this is actually the basic of the integration or the calculus. ds equivalent to dx v square plus dy v square, like that, and then v square root. So this is actually theorem Pythagoras, if you are already familiar with this formula, right? Substituted in So what is the x is minus a sine theta, so we square becomes a square sine square theta, and then theta square, plus dy square, which is p square cosine square theta d theta square, and then we need to square root them all. And remember, we still have theta square inside the square root, so we square root the theta square becomes, d theta square becomes d theta only outside of the integration, like that. Alright, so it's very simple. And then using the relation of sine square theta plus cosine square theta equals to 1, so we can simplify this. So I want to change this becomes 1 minus sine square theta, right? Okay, so it's a square sine square theta plus b square 1 minus 1 minus sine square theta d theta. And then simplify a square sine square theta plus b square minus b square sine square theta d theta outside of the integration. Then we can factorize the, well, let me see, factorize which one, yeah, the b square, right? The b square we can factorize. So b square inside the square root becomes b. So a square divided by b square, so a over b square sorry, maybe I can factorize the sine square theta also. So it becomes sine square theta. Okay, we factorize sine square theta becomes a square over b square minus 1 plus 1, right? D theta. Okay, let me check back. Okay, a square. Yep. Alright, so we are going to solve the integration. So I will put the 1 in front, sine square theta, and then I will let this to be k square. Okay, so that one is k square. Okay, I will let the bunch of a square minus b square minus 1, a square over b square minus 1 to be k square. Okay, so yeah, this is our elliptical integration. And remember, this is not our final answer because this is in the form of ds. So we need to integrate from 0 to 2 pi, right? Because our ellipse is from 0 until 360 degree, which is 2 pi. But you need to remember that our sine is an sinusoidal function, so it is ranging from 1 0 minus 1, like that. Because if you realize the graph of the sine theta, it's like this, right? So starting from theta equals to 0, pi and then 2 pi. So this is pi over 2 and 3 pi over 2. So we have 4 portions of the angle over here, or 4 quadrants, and each quadrants give you different value. So you cannot integrate all the way along from 0 to 2 pi over here. Okay, so you need to consider only the first quadrant, for example from 0 to pi over 2. Okay, so this is the first quadrant, so we need to integrate until 4 quadrants. So because the quadrants are symmetry, okay, so we just multiply by 4 like that. So it's very simple. Okay, so this is becoming the S, and S, or the perimeter, is basically this is elliptical integration given by 4 times with the, so this is the first kind of the elliptical integration, so E K. So K, our K is A square minus B square. Sorry, A square minus over B square minus 1. Sorry, B square minus 1 square root pi over 2. Okay, so we need to look at the table of the elliptical integration, because we cannot solve this analytically because it is hard and difficult, so we need to use some kind of help from the table. Okay, and yeah, so we need to substitute the value of A and B for the original question given here. So over here is let me x square over 49 over 9, which is 7 over 3 square, plus y square over 7 over 4 square equals to 1. So we know our value of A is here. This is A and this is B. So A is 7 over 3. So 4 times the E, 7 over, so it's 7 over 3 square, 7 over 3 divided by 7 over 4 all square. So this is 7 over 3, 4 over 7, so it's 4 over 3 square. So it is 16 over 9. 16 over 9 minus 1 is 16 over 9 minus 9, minus 1, which is 9 over 9, right, is 5 over 9, 7 over 9. Okay, so 7 over 9, so it's square root 7 over 9, or 7 over 3 pi over 2. Okay, so in order to find the numerical value, we need to look at the table. Okay, so let me use my table to look for the answer, the numerical answer. So I got 1.193, which is approximately 1.193 times 4 is 4.772. Okay, unit, like that. Okay. Alright, so let's proceed to the next question. Alright, so this is our second question. To evaluate the integral of this third form, Okay, so integration of 0 to 1, square root 100 minus t square divided by square root 1 minus t square dt. So if you realize that we have two square root over here, and I guess this should be clear for you to see that this is, of course, has to do with the elliptical integral. Okay, but the limit here is not so suitable for the use of the elliptical integral, but we can use the use substitution or the substitution, which in return we can get our desired limit of integration. So we now let t becomes sine of theta. Okay, maybe I can use another color. And then dt is just cosine of theta d theta. So this is the limit of t. So when t goes to 0, we have theta goes to 0 too. Okay, fair enough. And if we have t goes to 1, so the upper limit, theta will goes to, so let's see. So this is 1, so sine theta equals to 1. What is the value of theta satisfied? Pi over 2. Yep, pi over 2. Hence we can transform our integral to be integration theta from 0 to pi over 2. So 100 minus t square, square root 100 minus t square. So t is sine theta, so sine square theta, all divided by 1 minus t square, which is 1 minus sine square theta. So all square root. So dt is cosine theta d theta. Okay, so we know that this 1 minus sine square theta will becomes cosine square theta. So square root of cosine square theta will becomes cosine theta, and cosine theta will cancel with this, right? So we will have integration from 0 to pi over 2, 100 minus sine square theta d theta. We can factorize the 100. 1 minus 1 over 100 sine square theta integration from 0 to pi over 2 d theta. So we can pull out the 100. So 10, 0 to pi over 2, 1 minus, so 1 over 100 is just 1 over 10 square, sine square theta, oops. Okay, pi over 2 d theta. So we know that this is k equals to 1/10. So this is the elliptical function of the second kind. K is 1/10, and our phi or the angle is pi over 2. So we need to look on the elliptical table in order for us to find the numerical value for it. So let's go. 1/10, so it is 0.1, sorry, 0.1, 0.1, so it is 10 times 1.5669, which is about, well, 15.7. Okay, so that's our answer. Yeah. Alright, the last question is to prove that this integral on the left hand side is basically equivalent to the elliptical integration on the right hand side. Okay, so right hand side basically equivalent to square root 5 integration from 0 to pi over 2 1 minus sine to 4 over 5, right? 4 over 5, because this is the value of k, this is k, and this is phi. So k square sine square theta. So k square is 4 over 5 basically, sine square theta d theta. So if you see our left hand side is plus 4 sine square theta, and this is minus 4 over 5 sine square theta with the additional square root of 5 outside. Okay, let's bring out our definition for the elliptical integration of the second kind. So E for a given parameter k and phi is actually integration from 0 to pi over 2, sorry, from 0 to pi 1 minus k square sine square theta d theta, and then the condition or the range of value of phi should be between 0 and pi over 2, and the value of k should be between I think it's from 0 wait, the range of k is supposed to be between minus 1 to 1. Okay, so but if you see on the left hand side, our k is basically 2, right? Because 2 squared is 4, so it is out of the range, so we cannot let 4 as our k values or k as the parameter of k. So the range is good because it is within the range of phi. So what we can do is basically to manipulate our left hand side. Okay, left hand side is given by integration from 0 to pi of 2 1 plus 4 sine square theta d theta. So I want you to realize that sine square theta is basically 1 minus cosine square theta. So I can rewrite this to be 1 minus cosine square theta, okay, using the basic identity. Okay, then we try to expand the set. It's 1 plus 4 minus 4 cosine square theta, integration 0 to pi over 2 d theta. Okay, so that's one is 5 minus 4 cosine square theta. So integration 0 to pi over 2. We can factor out the 5 and then bring it outside. So square root 5. Integration 0 to pi over 2. So it left with 1 minus 4 over square root 5, 4 over 5, right? So 4 over 5 cosine square theta. So this is our k square. Okay, our k square. So we can change it to be set 5 integration 0 to pi over 2, 1 minus, so it's 2 over square root 5 square cosine square theta d theta, don't forget d theta. So this is our k value. So 2 over square root 5 is our k value. So I want you to realize that, and I want to convince you that this integral is basically the same as our general formula, even though it is differs by the sign. Okay, because so which means that, so I will move the limit first. So actually this is actually equivalent to the integration from 0 to phi 1 minus k square cosine square theta d theta with the same limit applies. Okay, why? Because if you realize that this is cosine square theta and that one is sine square theta, so if you try to draw the basic graph of sine theta first, it will look like, for sine theta from 0 to pi over 2 only, it look like that. So this is pi over 2, and for graph for cosine, it looks like, so the amplitude until pi over 2, so the amplitude, so like that. So it is actually similar. So this is for sine theta and this is for cos theta. So if you see, they're actually similar within the limit 0 to pi over 2. Okay, so it is kind of just the reflection within the y-axis, right? So with that being said, and also additionally, the range of value of cosine square theta is from 0 to 1. Okay, so the range of value for cosine square theta is from 0 to 1. Same goes with this. So the range of value is from 0 to 1. So they have the same range. So we can conclude that they're the same thing. Cosine square theta and sine square theta inside the elliptical integration are the same thing. Okay, so I have given you two proof or two explanation to convince yourself that this and this are the same. Okay, they are the same. So this is the alternatives of the elliptical integration in the cosine square term. Hence, because they are the same thing, so we can rewrite this as the elliptical integration of the second kind, 2 over square root 5 as the parameter k, and then the angle is pi over 2. Then we prove it. Okay, we prove that. Right, so it is exactly the same. Okay, so which means this is right hand side proven. Okay, so yeah, that's all for this revision for my math course. Yeah, till next time, bye bye.